Hello and welcome to another session Data with Nick the Greek. So today it's finally getting a little bit more exciting. So we're gonna start doing what we usually do, loading and saving data. Of course, still with a focus of partitioning. And today we're gonna start with the saving part to really see how the partitions we started to investigate behave when saving data based on Parquet. And yeah, let's jump straight into it. So as always, we are setting up our Spark partition and having our data set with our ID column, date times the ID string. And those are just some evaluation functions which we gotta use later on to evaluate the number of partitions, number of rows per partition, and also the percentages out of it. So if you want to test this notebook later on, I'm going to load it, of course, as always, into my GitHub account. The only thing you're going to need to change is your base path. So if you don't have a departition or working on Azure Databricks, for instance, then of course, you're going to add your ABFSS path here to perform those tests. All right, so we're gonna be looking on a data set with hundreds. No, let us count together. 1 million rows today to not save too much of data. And the first question what we want to investigate is how many files are written based on the number of partitions. And I guess if you follow the previous sessions already, you probably guessed it already. It depends on the number of partitions you have on Spark partitions you have within your data set. Also, as we gonna be looking onto Parquet, I added a nice link which gives a good deep dive into Parquet. That's something we will not do today, but we're gonna look there for a little bit under the Spark UI also, what's happening behind. All right, let's save our first data set. So base directory is dspark data. And then we just create here a Parquet file, which is test1 file. And so now we're gonna start writing only one partition. So you can also see the number of partitions is 1. And if you're gonna open our Explorer, you see here is the Parquet file. And as you might already know, it's basically a folder with multiple files into it, but the most important file, you can also see it is around 8 megabyte, is basically this snappy.parquet file where the data is really included. I think those files, I have to admit, at this stage, I don't know exactly, but I think there are some metadata just included regarding the Parquet file. All right, let's do the same thing with a different number of partitions. Let's go back to VS Code. Run it now with 4 partitions. You can also see 4 partitions. And to not jump back and forth together, we're also gonna do it with 12. And I mean, I guess you already got the point. If you have 4 partitions, we're gonna get 4 snappy encrypted files. And if you're gonna do it with 12, we're gonna get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So basically the assumption is already correct that we gonna get generated 12 Parquet files. And I mean, the reason is quite simple. It's still trying to parallelize what Spark is doing. It pulls the 4 partitions, saves them as Parquet file, continues with the next ones. And I mean, that's really important for the optimization and performance. Writing to the same file would be, of course, a little bit more unperformed because the parallelization will not properly be working. Yeah, that's actually all about writing already. And let's have a look into the Spark partition just to have a look how it looks like. So we have 3 jobs here, writing 1, 4, and 12 files with 1, 4, and 12 partitions. And you can see we only have 1 stage, so there's no shuffling happening logically. That's why we have only 1 stage. And when you also look at the duration, you see also for the writing, it counts again, have some parallelism regarding the number of partitions. You can see that one partition is 3 seconds to write, and 4 partitions get to 8 seconds. And I mean, the reason is easy. You just gonna have, when you're looking into the stage, one big task, and by the way, you can then also see how many records have been saved, 8 megabytes. And I mean, the values are here always the same, as we only have one partition, one task, which we are writing to. If you're going back to write 4, you can see now in this stage, all right, we have 4. Well, there's still some deviation during the writing, but still we have like 4 more distributed parallelized partitions and tasks. And the same thing if you're gonna be looking on the 12 file partition. So let's jump again here so you can see 12 tasks. And yeah, I mean, here we already see we're scratching slowly the 100 milliseconds. I think the 12 one was a little bit slower, but I mean, we're talking low data. There's always some slight deviation, of course, especially if you run it on the local computer. But it could be a little bit more performant if you wouldn't go with 12 partitions, as we don't have that much data this time. 83,000 rows, 600 kilobytes is the output size per file in this case. Having a look into the SQL data frame, let's take the 4 one in this case. It also gives you some nice overview and statistics. So we have 1 million of rows as discussed at the beginning, and then it also tells us here how many files have been written, how many rows, and what's the output size of the files. So that's basically in a nutshell what happened on the Spark UI. Now we said in the past, like coalesce can be used or could be even useful for writing data as well as repartitioning. And I mean, we already talked about it. Sometimes you want to reduce the number of partitions or have bigger files due to the reason that you had smaller files or partitions when receiving the data. And of course, you can do this with coalesce or repartitioning. So let's just execute those 4, and we see the number of partitioning here for 1 for 1. And also, if you're gonna go to Explorer again, you're gonna see, okay, here we have the 1 file which we wanted. Here we have also the 1 file when we're doing with repartitioning. Then with coalesce 4 files, and repartitioning also 4 files as we wanted. Yeah, let's have a look what's happening in this case in the Spark UI. So we have our coalesce. Let's have a look first of all the total execution time. So you can see that coalescing to 4 is faster than coalescing to 1. The reason for that is then when you coalesce, you have a narrow transformation and just 1 core is used. With repartitioning, it's a little bit different. So at least for the first part, you can also see here a big part is done is done by all the cores, and only the final part is done by executed by 1 core. So there you use a little bit more your distribution. So in some cases, it can be that repartitioning is actually more efficient than coalesce if you do coalesce 1 in this case. yeah, let's have a look into coalescing down to 1, for instance. So you can see, okay, we again have like this very big partition. 8 megabytes is the data size we have, and the same behavior roughly in the second task when we execute with repartitioning. So now the next question you might ask yourself, what is happening with this problem we had before with empty partitions? So you remember we had a data set where we had 20 partitions initially, and I hope you still remember when you filter, the number of partitions are not changing. But when we are analyzing the number of the partitions and the number of rows per partition, we realize, okay, only one partition is data. And I mean, it would be horrible to have like 0 kilobyte files basically saved, because we're gonna learn later that those very small files or even empty files can, similar to empty partitions, just create scheduler effort, which you just don't want in your system. And yeah, let's have a look into the storage account. What's the result? So empty rows, Parquet, and lucky us, it's smart enough only writing one of the files and not additionally 19 empty files. So that's basically a pretty good thing. I can tell you that I saw 1 or 2 cases, let's see if we gonna be the case in a bit as well, where a 0 kilobyte file really has been written, but I ran this with multiple configurations, and usually you really only write the partitions which actually have records and data inside. Also looking into the Spark UI, we're gonna see that now looking on the job, it's significantly faster as we filter down data. We are not writing a lot of data, so this makes pretty much sense. We can also see that yeah, the partition which actually has data, that's the ID number 1, that's this one. No, the task number 0 actually. That's the one here, and that's also like the longer task you have. And I mean, it surprised me that we have a lot of deserialization time here. But yeah, doing the right operation seems to be a little bit more yeah, handling here. Of course, we have also quite a lot of partitions now in this case, for the amount of data. Looking also into the SQL part, you can see here, so we have a number of 1 million rows. We filtered them down to 200. 200 rows remain, 200 we save, 3.4 kilobytes we save, which is a really small file. And yeah, and the number of files we can see here. So, and now the last thing we want to have a look, you also realize that we have empty partitions sometimes when we're doing repartitioning. And I mean, the reason for that is basically the hash partitioning happening in the background when you're doing doing repartitioning based on the column. So if you're unlucky that the hash has a similar number or a number which has the same modulo value in the background, that's how it's working. That's something we can have a look on another course. It just ends up in the same partition, so it's not distributing the data sometimes really well. And let's have straight away a look here. So here we have again our 20 partitions initially and repartition down to 10 based on the column ID first. And when we're looking on the data frame of the results, we see, okay, we have 6 partitions actually only with data available. And let's also have a look into the generate Parquet file, and we set 6. And here, yeah, there we have one example. So you can see this 1 kilobyte file. And I mean, those are the files where there's data, and this kilobyte file is just empty. Actually, let's have a look into the data. So let's do SDF read.parquet and copy the path which we have here, and then additionally the file which is kilobyte file. So let's just copy that, and then let's do a dot show. Okay, beginner mistake. Of course, we want to do spark.read, and yeah, well, all we can see is the data frame is actually empty. So there's really no data in this partition. Let's try the same thing for another data set. So also again here we're going down to 8 partitions. 6 of them are filled with data. So actually pretty much the same, but let's see if you're lucky that we don't have any empty partition here in this case. And yeah, in this case it works quite well. So basically in this case indeed the 6 partitions which include data actually have been saved. And yes, we like doing it. Let's have a look on the one job where we had like more data as we expected. So it was a repartitioning from 20 to 10. We can see here the task execution for before the shuffle write, and then when we're actually doing the write towards disk. And yeah, I mean, it's also quite interesting. We have here some very small tasks. Those are probably the ones which barely are writing data. And yeah, I guess those 1, 2, 3, 4, 5, 6 big ones are the ones which actually have a lot of data. So you can also see, in this case, a little bit undistributed when you're writing, because this task really holds up the whole process in this case. And I guess that's the one with 0 kilobytes, and those are the ones which basically don't write any data at all anymore. So we are coming up to 10. And yeah, let's see also if you're gonna see the same thing here. Yeah, 7 files are written, and 1 million rows, 8 megabytes. So there you can also see those results. Okay, that's pretty much all it. I hope this made a little bit transparent how the writing process is looking like, and of course this features how to save the data. We're gonna play around a little bit with the loading parts and how the partitions behave when you're loading the data next time based on different distributions of a file. So stay excited, stay tuned. If you like this video, feel free to subscribe the channel. And as always, if you have questions, if you have comments, if something is missing or was incorrect, feel free to just comment below in the channel under the video. And yeah, until next time, ciao ciao.